All right, hello everyone. I had a request for page 2 of this practice test. This is practice test number 2. Number 2, page 2. I'm going to do some of the problems on here. All right, here we go. Solving this log equation right here. Well, first thing I see is that there's the log of both arguments here are the same. So we can just cancel out the logs. Yes, it is that easy. 3x plus 7 equals 2x plus 5. Now we can subtract that over, x is negative 2. It is that simple. The idea is if you have the same logs, then the arguments have to be the same. Kind of like this problem right here. If I say 5 to the a equals 5 to the second, well, we know that must be a 2 right there because the bases are the same, so the exponents are the same. Log's the same, argument's the same. Same deal here. So we have 4p squared plus 9p equals 10 plus 3p squared. Subtract that over there. P squared plus 9p. Why don't I subtract that over there also? Equals 0, and I'll leave it to you to solve there. You're going to have to factor that. All right, but when we get down here, now we don't have the same log on both sides, and if I put it over to that side, I'm going to have that 2 in the way. So the other idea is to use a property of logarithms that says if you are adding two logs, it's the same thing as multiplying them. So I can just rewrite this problem like this. These two multiplied together is the same thing. And then now what can I do? I can change it to exponential form. That'd be 6 squared would be 36 plus 5x. Bring that over there and factor. All right, now when I only have one log, all I have to do is switch it to exponential, but I have to divide by 7 first. So if I divide by 7, I still have that, and this is log base 10, of course. Now exponential, 10 to the 0 equals 10m. Well, that's just 1. Divide by 10, m is equal to 1/10. All right, and the calculator, how do we do this? Well, we use a change of base formula that says this is a log problem that's base 2. And our calculator doesn't compute that. So what we do is we say the log base 10 of 3 over the log base 2. And now we can get it done with our calculator. I typed in the log of 3 divided by the log of 2 is about 1.585. Again, the next one, log of 22 over the log of 3. Log 22 right there divided by log of 3. All right, and down at the bottom, it's just a matter of putting an x there and changing it to exponential form. What exponent do I need? 7 to the 3rd, I think. There we go. X is equal to 3. Now when you get to this one, a little bit trickier, we have 6 to the x is equal to 136. Well, let me rewrite this. This is 6 to the x, and this is really 6 to the negative 2, because 6 to the negative 2 means 1 over 36. And now look, base is the same, exponent's the same. I'm going to do one last problem, 22. Put an x here. 8 to the x is equal to 4, and people have trouble with this because how do you take an 8, turn it into a 4? Well, obviously it's going to be some kind of fraction. It's not going to be a half though, because what does 8 to the half mean? Well, that means the square root of 8, and the square root of 8 is not 4. So what if I rewrote this as 2 to the 3rd, and I rewrote this as 2 to the 2nd? 4 is 2 to the 2nd, 8 is 2 to the 3rd, and now I can multiply those out, and now I have same basis, so 3x equals 2, x is equal to 2/3. All right, hope this helps with page 2.